Alright, physics fam, we are headed into free body diagrams, but applying it to Newton's second law. And to do that, let's do a couple examples. So from this one, this is from our 5th worksheet called Drawing Free Body Diagrams. We have to read, draw the diagram, and basically get everything we can out of the information given. So let's do that. Alright, so it says a 2 kilogram bucket, so we've got a mass here. I'm going to draw my free body diagram down here just to get my space. So I've got a 2 kilogram bucket. Alright, it's tied to a rope and accelerated upward. Alright, so a little hint there, we're accelerating upward, alright, in a well at a rate of 1.5 meters per second squared. So if we're talking about up and down, right, that is the y-axis. So we know then that the acceleration is a positive 1.5 meters per second squared. That's given to us. It says forget air resistance, so we're not worried about that. We want to diagram the forces acting on the bucket. First of all, are there any forces moving to the left or right, basically in the x-plane? The answer is no. So that means there's going to be net force in the x direction, none, and there's going to be no acceleration either. So those are goose eggs, zeros. So we are only concerned in the y direction. Now, it is accelerating upwards, which means the net force overall is in the upward direction, because we know that whatever direction acceleration is in, net force is in the same direction. So that means that this force going up is going to be larger than the downward force. I think we can assume the downward force is force of gravity. And if this is a rope that's pulling the bucket up from a well, I'm assuming that rope is the force of tension. So let's write that, force of tension. Alright, so we want to solve for that, and we also want to make sure we solve for the net force, and we already have the acceleration. So let's do that. Okay, what can we figure out first? Well, if we have the mass, we know then we can figure out the weight, because the force of gravity is equal to the weight, and weight is equal to mass times gravity. So let's do that. Mass is 2 kilograms. Gravity is negative 9.8. When we multiply those two together, we end up getting about negative 19.6 newtons. So it looks like in the downward y direction, the force of gravity is negative 19.6 newtons. Alright, now the tension of force going up is not equal, because we know we have acceleration in the upward y direction. Alright, so there must be another way to figure that out. Well, I can figure out my overall net force, I think, up here by Newton's second law, which says net force is equal to mass times the acceleration. I know my mass is 2 kilograms, and I know my acceleration is 1.5. Multiplying 2 times 1.5, I end up getting a net force of about 3 newtons. So I can put that in my answer right here. I have 3 newtons. Now that I have that, I know that I can finally figure out my force of tension. And it's simple. My net force is really just the sum of all the forces added up in the y direction. So my force of tension plus my force of gravity. And remember, that's in the y direction. So we can plug in for that. I know that my overall net force is 3. I have no idea what my force of tension is, so I'm going to leave that as a variable. But I know my force of gravity is negative 19.6. If I want to solve for that, I'm going to add 19.6 to both sides. And when doing that, I get 3 plus 19.6 will equal my force of tension, which of course then is 22.6 newtons. So now if we want to clear that up, what did I need to find for all my answers? Well, I've got my upward force of tension, I've got my downward force of gravity, I've got my overall net force in the y direction, and my overall acceleration in the y. I do not have anything in the x, so that makes sense that these guys are 0. And I think I've solved for everything I needed. Hopefully you followed along with that, and hopefully that helped out. It does all start with the free body diagram, though. Make sure you are confident in what you're drawing, and then start finding the numbers wherever you can. Let's try out number 5 as well. It says a 2 Newton force overall is applied to a 1 kilogram book in order to move it across a desk with an acceleration of 0.5 meters per second squared. Now, if you're moving it across a desk from left to right, that is the x coordinate. So that means I already know my acceleration is 0.5 meters per second squared. All right? It doesn't appear that the book is moving up or down, so there's no acceleration or net force overall in the y direction, which is up and down. Now that doesn't mean there's no forces acting on it, it just means that in the y direction it's in equilibrium. Alright, let me draw the free body diagram for this one over here. This object is about 1 kilogram. I like to put the mass in the middle. Obviously the force of gravity is pulling down and the table is pushing up by the same amount. That would be the normal force. Eventually I want to get those numbers. Besides that, I also want to figure out my x direction forces as well, which is left to right. There's a 2 Newton force applied to the book, so that force applied forward, all right, is going to be 2 newtons. I already have that. And that means there's going to be a force of friction. Now since the acceleration is positive and the book is speeding up, I can assume that my force of friction opposite that is slightly less. So I'm going to leave that there as the force of friction with the smaller arrow. Alright, now we have to just start figuring out where we can start plugging in. And it doesn't necessarily matter where you're going to do it, but for me, I like starting at force of gravity because as long as I know the mass, I can figure out the weight, which is the force of gravity. So I'm going to do mass times gravity. The mass is 1, gravity is negative 9.8. My overall weight and force of gravity is negative 9.8 newtons. Easy enough. Now, because this is negative 9.8 and we're in equilibrium in the y direction, I can assume that my normal force up is also 9.8, but not negative. It's got to be positive in the opposite direction. But now I solve for that as well. The only force I need to solve for now is my force of friction, and then of course I need to figure out my overall net force. My net force should be easy though, right? Because of Newton's second law, F equals ma, my mass is 1 kilogram and my acceleration is 0.5. When I multiply them together, I end up getting an overall net force of 0.5. So I can put that right here, 0.5 newtons. Alright, so my last part is figuring out this force of friction. But remember, my net force in the x direction is equal to all the forces going left to right. So I have force of friction plus my applied force. Now I already know my applied force is 2. And I already know my net force from here is 0.5. So all I need to do is figure out what my force of friction is, which really is simply subtracting 2 to the other side. Well, what's 0.5 minus 2? It's negative 1.5. So that means that my overall force of friction is negative 1.5 backwards. Did we figure everything out that we needed? Yes. Every single force is given a number, and my net force in the x direction and acceleration are accounted for, as is my net force and acceleration in the y direction, which ended up being in equilibrium. But overall, I've used Newton's second law, I've used my weight equals mass times gravity equation, and I've used the idea that my net force is all the forces added up in order to figure out everything else. It's an application of everything we've learned so far, but hopefully that made sense and was helpful for you guys. Thanks for listening. Hope this was a good support. Keep trying hard and keep asking questions in class. Good luck.